So we have made a kit here in which we can control our electrical and electronic appliances and devices using a DTMF based cell phone. So as you can see here, for demo purpose we have connected 4 AC bulbs and we have given the AC output here, and we have given an AC input here. So the main ideology is that whatever kind of output you require, the same kind of input you should provide. So for an AC output, you should have an AC input, and for DC output, you should have a DC power input. So I'll show you the demonstration. So this is a DTMF based cell phone, and the ideology is that you need to call on this DTMF based phone from any remote phone through which you have to control this kit or your appliances. So as soon as you receive the cell phone, as soon as you receive the call here, so you can give inputs from your cell phone. So as you can see, at keypad 1 it turns on, keypad 2 turns off. Similarly, at keypad 9 all the 4 bulbs turn on, and at keypad 0 all 4 turn off. So we have programmed this in such a way that all the odd numbers are for switching on and all the even numbers are for switching off. So the principle behind this project is that the DTMF tones which are generated from a DTMF based cell phone is detected by this jack, and it is sent to this microcontroller, which is a DTMF decoder. Now this DTMF decoder converts them into binary inputs to the microcontroller, and this this microcontroller then sends the output signal to these relays accordingly. So you can order this kit from our website www.kitsguru.com, where you will find 2 versions of the kit. One where you'll get this ready-made kit as you can see here, and the other one where you'll get all the components separately, and you can assemble those kits and solder those components using our video tutorials. So in this section of the video, we'll see what all components are used in the kit, and what are the functions of those components, and how the PCB has to be assembled with all the components, and how we connect the 2 PCBs with each other, and how do we convert this set of components into a complete working kit. So for reference, as you can see, we have a ready-made kit here, and with the help of this ready-made kit, we'll assemble all the components together. So first we'll take a look at the PCB. So these are the 2 PCBs, and this is the main PCB which has the microcontroller in it. So a PCB has generally 2 layers. So this is the top layer where you insert all the components, and this is the bottom layer where the copper tracks are present and where the soldering takes place. So the technology that we use is called a through-hole technology, in which we drill the holes from the top layer throughout the PCB, and then we assemble or insert all the components at the right position with the right alignment, and then continue with the soldering. So first we'll take a look at the main PCB and assemble all the components on this PCB. And so basically there are 3 sections in this PCB. First is a section of the power supply, then is a section of the main microcontroller, and the third is a section of the DTMF decoder IC. So for reference purpose, I'll keep my blank PCB in line with the ready-made kit so that we understand the alignment and direction of each and every component as we fix them. So we'll start off with the section of the power supply. So as you can see, we have provided a jack here in order to give supply through an adapter. So jack goes here, and then we have provided an on-off switch. So this on-off switch lets you control the power of the entire circuit. And then suppose you give an power supply through a transformer. We have provided a bridge rectifier. So a bridge rectifier converts the AC input into a DC output. So when you take a look at the bridge rectifier, you'll notice that there are 4 terminals. So 2 terminals are for the AC input, and the other 2 terminals are for the DC output, which is indicated by the plus and minus symbol. So while inserting the bridge rectifier, we need to make sure that the positive terminal, which has the longest stem, this is the positive terminal, has the longest stem. So this is at the bottom right. So while inserting, we need to make sure that the positive terminal is at the bottom right. The rest of the pin will align by itself. And in order to remove all the AC repulses or the fluctuations which were produced during the rectification, we provide a 1000 microfarad capacitor. So even this has polarity. It has 2 terminals, positive and negative. The stem which is longer in length is positive terminal, and if sometimes both the stem are of equal length, you'll notice that there's this blue strip which indicates that this is a negative terminal. So while inserting, we have to ensure that the positive terminal is at the right side, which is in line with the positive terminal of the bridge rectifier. So, and then we connect a 2-pin connector. So this is connected so that we can give a parallel power supply to the other PCB. And this entire circuit, all the components usually work at 5 volts. So we need to convert the 12 volt input into 5 volts output. For that, we use a 7805 voltage regulator IC, which converts the 12 volts into 5 volts. So when you take a look at this voltage regulator IC, so this is the front face, which has the specifications written on it. So the left pin is the first terminal, which is the input. The middle pin is the ground, and the third terminal on the right side is the output terminal. So while inserting, we need to ensure that the first pin is on the right side. So you'll be facing the rear side of the voltage regulator. Also, there's this LED which indicates the power. So we'll insert this LED. So even LED has polarity. So you'll notice that there are 2 stems. One is longer in length. The one which is longer in length is the positive terminal. And if both the stems are of equal length, you'll notice that the bulb is usually round. This LED bulb is usually round, but at the negative terminal, it gets flat. So the flat side of the bulb indicates that this is a negative terminal. So while inserting this LED, we had to ensure that the negative terminal is on the right side. And along with the LED, we also provide a resistor of 1K. So this is to protect the LED from blowing out. So this completes the section of the power supply. Next, we'll come on to the section of the microcontroller. So this is the microcontroller. Now you can connect the microcontroller directly, but we usually provide an IC base. Sometimes what happens is while soldering, your microcontroller might get damaged due to overheating. So to protect the microcontroller and to replace it in case in the future, we provide an IC base. So when you take a look at the microcontroller in the base, you'll notice that there's a notch at one side. So this notch, when you keep the notch on the top side, so the left pin on the top is the pin number 1. The pin left to the notch is the pin number 1, and then you have to count counterclockwise. So the right pin at the top is the pin number 40. So while inserting this IC base, even this has a notch, so we have to ensure that the notch is on the left side. As you can see, this is on the left side. So once the IC base is fixed, the microcontroller is also inserted with the notch on the left side, and then we fixed a network resistor. A network resistor is a cluster of 8 resistors, each of 10 kilo ohm. So this has totally 9 pins, and when you see the network resistance in front of you, you'll notice there's a dot on the left side at the black surface. So while inserting the network resistor, we need to make sure that the dot is facing you. So and the dot is on the left side. So the dot is on the left side. So this is how it's inserted. And then to give the output from the microcontroller, we connect a 4-pin connector. And this microcontroller works on a clock frequency. So for that we provide a crystal oscillator of 10 megahertz. And along with a crystal oscillator, sometimes the oscillator is not able to start its oscillation. So for that we fix 2 capacitors in parallel of 33 picofarad each in order to start the oscillation process. Then we have a reset switch in order to reset the microcontroller, and we keep the reset switch pulled down with a resistor, 10K resistor. 10K has a color code of brown, black and orange. So this completes the section of the microcontroller. Now we'll come to the next part. So in the same way, we have an IC base for this DTMF decoder IC. So while inserting this, we need to make sure that the notch is at the bottom side, which is facing you. So this notch will be facing you, and the DTMF decoder IC will go over it with the notch towards you. And even this runs on a clock frequency. So a crystal oscillator of 3.5 megahertz will be inserted here. Along with it, we fix 2 capacitors of 33 picofarad. Two resistors of 100K, color code brown, black and yellow are inserted here. These are necessary components which ensures that the DTMF decoder IC runs smoothly. And then we insert this IC104 0.1 microfarad capacitor, and in order to take the input, DTMF input from the cell phone, we insert this connector, 2-pin connector. Then you will see there's a indicator, an LED here. This LED blinks whenever there's a detection of DTMF signal. So while inserting this LED, we need to ensure that the negative terminal is on the right side. And the resistor of 1K with color code brown, black and red goes here along with the LED. Another IC 104.1 microfarad capacitor is inserted here, and a resistor of 330 kilo ohm with color code orange, yellow goes here. So in order to pull down the output of the DTMF decoder IC, we insert 4 resistors of 10K. A 10K has a color code of brown, black and orange. So you need to take care of the color codes while inserting the resistors. So once we finish fixing all the components, you also have to make sure that you keep soldering all the components once you keep fixing them. Okay, for soldering we have another video tutorial which you can refer. So once you finish this PCB, we'll move on to the next one. So this is the other one. So we'll see what components are used in this. So first we'll insert a 4-pin connector, which is the input from the microcontroller. Then we insert a 2-pin connector for the power supply. Yeah. Then we insert this IC base. Now the notch of the IC base has to be away from you. So this is here, away from you. And the ULN driver, which is a relay driver, high current driver, goes on top of this IC base. And then we'll fix all the relays, the 4 relays. A relay has 5 pin at the bottom, so necessary holes have been provided. So as you're fixing all the relays, you can keep soldering them. So after fixing all the relays, we'll make sure that there are 4, we'll see that there are 4 output terminals, 1 from each relay and 1 input terminal. And along with that, we have 4 LEDs, which indicates which relay is active. So first we'll connect the LEDs. So while connecting the LEDs, you need to ensure that the negative terminal is facing you. So along with the LED, we'll also connect a resistor of 1K to protect the LED as mentioned earlier. So this way you'll connect all the LEDs, and this is the input terminal, and the output terminal will be connected here. Similarly, all the other terminals can be connected. You'll also see a bunch of jumper wires, metallic wires, so you can connect them. We'll provide you with the wires. You can peel their outer layer and then connect it. So once you've finished all the connections, before fixing or before connecting all the microcontrollers, we'll check the power supply and we'll see if the adequate power supply is given to all the components before we connect all the microcontrollers and the ULN driver. So to check the power supply, we'll use this digital multimeter. So the black pin is the common terminal, so which will be attached to the body of the voltage regulator IC. So first we'll check the power supply at the first pin of the voltage regulator IC. So this will show your power supply. So currently we are giving power through an adapter. So this is showing the voltage of the provided by the adapter, and the third pin should show the voltage of 5 volts as we require 5 volts at the output. Pin number 40 should show 5 volts. Pin 40 of the microcontroller, so counting counterclockwise, the last pin is pin number 40, and pin number 10 pin number 18 of the DTMF decoder should show 5 volts. Pin number 10 of ULN driver should show the input power supply, input voltage. And while connecting the power supply from one PCB to another, we have to ensure that the positive terminal is connected to the positive terminal. We've also provided a diode. As you can see here, there's a diode. So this is provided in case sometimes we give power in reverse polarity. So this diode protects the circuit by rectifying that power supply. So we will check which terminal at this 2-pin connector is getting positive supply. So as you can see, the one which is facing you and towards you is getting positive supply. So that pin will be connected to the outer pin of the second PCB. As you can see, the outer pin is getting the power supply here. So we need to ensure that the positive terminal is connected to this positive terminal. And pin number 10 of the ULN driver should get the input voltage supply. So once this power is checked, you will carry on with fixing all the ICs and microcontrollers. So you'll also notice that there's this 3.5mm jack that we have provided, which has to be connected to the DTMF device. So this is the jack. Now once you open it, you'll notice that there are 3 terminals. So one wire has to be connected to the longest terminal, and the other wire has to be connected to the second longest. Okay, so once you fix the wires, you can finish the connection, and you can connect this to the DTMF decoder device. So you can order this kit from our website kitsguru.com, where you will find 2 versions of the kit. One where you'll get all the complete kit, working kit, and the other one where you'll get all the components separately along with programmed microcontroller, and which with our video tutorials you can assemble all the components. And we have another video for soldering, with the help of which you can finish all the soldering of the components carefully.